Hi folks, thanks for joining me here. I'm going to do a little signal tracing here on a working set, starting with the RF section and work back toward the loudspeaker. This is a kind of an all-in-one signal tracer that I built based on that last probe design. Everything's integrated here into one package, including and up to the LM386 that drives a Bluetooth device and or a loudspeaker in my case. Anyway, I want to go ahead and get started here on the RF section. I'll walk you through it and show the schematic as well, and I just want to point out a few things about how attaching the probe to different impedance points, that being the plate or the grid of the tubes, can impact the results of the signal tracer. So we'll use a high value resistor in addition to a picofarad value capacitor as well to mitigate some of those issues that you'll see. Let's get started. Since this radio is operating, I'm going to just leverage the outside signals I'm able to receive here. And for this particular radio, you can see this is the shortwave coil, the broadcast coil, and this is the combined oscillator coil in this example for the shortwave bands that this radio receives, as well as the broadcast band. So if you look at the schematic that I'm sharing, you'll see the tank circuit where the signal comes in here off of the antenna itself. And all the magic occurs back here to this first RF tube here. Now we can test the signals here on the grid of the RF tube right here on the band switch. So again, that's going to be a very high impedance location. So let's do so with the signal tracer here. And just make certain that we can hear the outside signals here. And for this particular example, I'm going to just stick with the broadcast band. Again, if we had problems in that upper band, the short wave band, we'd want to better understand the LC circuit and see what's going on there. It could be a problem with the oscillator itself and or the antenna coil here that could impact that band as well, in addition of course to the band switch itself. Let's go ahead and attach the signal tracer here to the band switch here at this location, again that being part of the tank circuit for the broadcast band here. So this is going to be sampling what's really being received by the RF tube here on the grid. So if I were to flip this radio over and go to the grid itself, which is at the top cap of the RF tube here, I would get the same results. So let's just see what we have here. As I mentioned, I'm only using the broadcast band at this time, but we know that our signal input coming through here, back through the broadcast antenna coil, and the oscillator circuit here is working. And we're actually receiving the signal here. Now let's go over to the plate of the RF tube. And let's listen in here and see what we have. Again, the grid is the input, the plate is the output, feeding that first IF transformer. So let's see what we have there at that location. For those following along on the schematic here, I'm going to attach the signal tracer here to the plate of the RF tube. And again, you've got very dangerous voltages here, so if you guys are following along, be sure that you have the training and knowledge to do so, or do so at your own risk. Now, what's causing the hum? There's a couple problems. You can still see that I have my resistor in place. The plate is not that high impedance location, so we need to remove that. So you see I've got these where I can just pop them off here. Let's reattach and see what we have. Still a lot of distortion. Again, you've got that DC voltage present. What we need to do is create a filter. So what I can do is actually insert a low value capacitor in this particular design, somewhere in the neighborhood of probably 20 to 50 picofarad. So you guys can see I've got the capacitor in there. Again, this capacitor is in series with the capacitor that's already inside. So the two capacitors in series with each other will still give me a capacitance just under the capacitance here, which is around 55 picofarads that I mentioned. So now you can hear we've got a useful audio that we're able to demodulate off the plate here just by selecting the capacitor to do two things. Again, to reduce the loading itself on the plate and not detune the circuit tremendously, in addition to act as a filter to remove some of those low frequency components that we're hearing. So you can see it makes a significant improvement and makes the signal tracer more useful in those situations. There's no grid connection here on the IF transformer. That's internal here to this first IF, so I don't want to flip this thing over. I'm going to sneak around here and touch the grid cap here of the first IF tube there, that being that 6U7.
Our lives, dislodging branches and even breaking off the business funding you need.
As I mentioned earlier as well, knowing that was a high impedance location itself, you can see I switched the probe back here to my resistor. Let's go to the plate here of the 6U7. You can hear the distortion again. We'll switch over to the capacitor like we did just a moment ago and see if that improves things. You'll notice a couple of things there. Again, with the capacitor there off the plate, we've reduced the hum itself. In addition, you can hear how loud the output is. And that's what you would expect. Again, the input being the grid, the output being the plate, and the amplification of the tube taking place. And you can hear how the gain itself is increasing as we go stage to stage. Let's move along to the next tube and look at the grid there. Then we'll sample the plate at that location as well. The 6P5 here is not very accessible. It resides here underneath the tuning switch. So we can test it here right off of the IF transformer itself. So let's see what we have there. Again, you can see I've got the resistor placed. So everything's working great there as well. We know the tube itself is working, the receiver's working, so we know we've got signal off the plate. Let's move past that here to the next tube. You can see here the grid of the 6F5 here attaches back to the wiper position here on the volume control potentiometer. So let me go here now. I'll have to crank up the volume here control. But let's see what we've got here. And in this case, you'll notice I've got the capacitor in. Again, this is more of a low impedance point that we'll be testing, so you'll get better results in most cases using a direct connect here without the capacitor, or in this case again I'm going to place the little 55 picofarad capacitor here on the end of the probe. That's with the volume down. So you're hearing both sources, of course, the loudspeaker here as well as the signal tracer at this point. Let's go to the plate here of the 6F5. So let's attach to the plate here of the 6F5, and again I won't use the capacitor itself, and let's see how much hum we have in distortion. And again I'll have to turn the volume up here, because we're going to be looking again at the output itself of the tube.
You just see things passing by the keyboard, because your sight line.
So you can hear some distortion there, but still if you're doing signal tracing and the receiver was dead, it would still be usable without the capacitor itself. So you can see how that cleaned that up again. And our final output tube here, the 6 Victor 6. We'll look at the grid first. Again, we'll have to turn the volume up, and we'll do the same here with the plate itself and see what we have. And that gets our signal over to the output transformer itself, which would feed the loudspeaker, which we know is working because I already have volume here and a good quality playing radio.
A gospel music artist. She is a pop artist who is saved. She really is.
So you can see everything's fine to that point. Let's go over here to the plate just for a second and see what we have there. Going to remove the resistor and just connect directly to the plate to see how much distortion we have, and then I'll place the capacitor in here.
The worship station.
So not too bad. Let me place the capacitor on here, and we'll repeat that just to see what we have.
Only way to make sure that the gospel community.
So you guys can hear everything's working fine. Again, on this particular example, again, I just wanted to demo the importance of how to change your loading and the impact and the improvements that you guys can see by using a capacitor itself and or a high value resistor itself to reduce the loading that you may find. Again, the sensitivity of the probe and the amplifier itself, if I'm around the output amplifier here, I don't even need to do a connection to that particular plate. There's enough signal here and amplification to drive this in a non-contact fashion as well. I appreciate you guys watching. Everyone out there, stay well and take care.